Welcome you all for the presentation Object-Oriented Programming with ADA 95. So as we know, software development has always involved using approaches to manage complexity because as the software is growing, it will become complex. So we should have some mechanism to manage that complexity. One well-known approach is called functional decomposition. So the functional decomposition divides the program which you want to perform into several smaller functions. Another approach is object-oriented approach, and this is also called as object-based approach. So the main difference between object-oriented and object-based approach is that inheritance is there in the object-oriented approach. Object-oriented program is an approach to implement using the object-oriented approach. Object-oriented program is a method of implementing in which the programs are organized a cooperative collection of objects, each of which represents an instance of some class, and whose classes are all members of hierarchy of classes united by inheritance relations. Mainly this includes you have some classes. These classes are defined, and instance of this class will be objects. So the all program will interact with objects to perform the intended operation. ADA was explicitly designed from the beginning to support the object-based approach, and in 1995 is extended to object-oriented programming. Object-oriented programming in ADA. So inheritance. First of all, I will explain you inheritance. Inheritance lets us define new types as extension of existing types. These new types inherit all the operations of the type they extend. The new types are termed as a children or derived types, while the types extended are usually called parents or base types. Inherited operations can be overridden with the new definitions of those operations. And in ADA95 terminology, types that can have parents or children are termed as target types and have the keyword tagged as part of the definitions. What does this mean is like you have one class and you declare that as a target type, and you can have the subsequently one more type with this as the base types. So this the subsequent types which you derived is called as children types, and the base type is called as parent types, and this is allowed in the ADA95. So how the inheritance happens? Just you see, this is one record which contains the figure and it contains the element start and contains the operations area, perimeter and draw. So now the circle is derived from the figure. So that means circle contains the all the methods and attributes of the figure, and additionally it contains the radius one more attribute, and it overrides the area, perimeter and the draw for its purpose. And the rectangular it is adding width and height in addition to the start, and it also have area, perimeter and draw. So square is also same level of the rectangle. So this example what we have seen in the previous slide in the block diagram, like you see the figure is a package, the point is a record, and the figure is defined as a tagged. So it contains the start of that point, and the next this is the procedures or methods of the figure, area, perimeter and draw. So now the type circle is extended, so this is called as a children type, whereas this is called parent type, or this is called a derived type, and this is called a base type also. So it contains additional radius also. So you have area, perimeter and draw. This overrides the function which is derived on the base types. So one more concept is polymorphism. So ADA also includes the concept of class. For each type there is an associated T class. This type comprises the union of all types in the tree of the derived types related to the T. So for example, in the previous example, rectangular class is a class that includes the type rectangle and square, and figure class is a class that includes the type figure, circle, rectangle, square. What does this mean is, for example, you defined the one base type as a target type, and the subsequent all children types you can access using the figure tick class. That's what it maintains. You see in the figure tick class, you can access all other children classes. Subprogram can define one or more parameters as a type of the form T class. Any type T or any of its descendants is acceptable for a parameter of type T class. You can pass that parameter onto the subprogram that expects the same T class without a problem. But what happens if the subprogram that accepted something of T class then tries to call some other program that requires the answer is dynamic dispatching? The dynamic dispatching is simply the process of determining at runtime exactly which routine to call and then calling it. So for example, in the previous example, you see area, perimeter and the area, parameter is there, draw. So these three, if you define in the runtime, you can pass it any class. So in the runtime, the compiler checks the base class which is there or derived class which is there to corresponding function it sends the control for execution. So this you see, this a figure class is defined. So here now, if you say area if, so this figure class based upon the function call of the figure print area, they may be calling the rectangular or circle or the square. The corresponding area is called. So this is what explained here. When the ADA program reaches the area if statement, it will note that the current type is a class type and the area takes only a specific type. Therefore, ADA will dispatch to the correct area operation depending on the specific type of the input by F. That's what it's saying. So only subprograms defined in the same package as the target type can be dispatched. These programs are formally called primitive subprograms. So the base program which are there is called primitive subprograms. Primitive subprograms should generally be defined immediately after the type is defined. So and here you see there's one monster is defined and the subsequent dragon is defined and the red dragon is defined one more and the person is dragon is this is a different one. So one more concept, as we see in inheritance and the polymorphism, this is encapsulation. So the figure and critters examples we have seen are public because they are defined in the open and anyone can access it. Thus, any user of those packages can read or change any of the data in those types. So ADA provides a number of mechanisms to hide the information from the user of a given type, making information inaccessible to others who should not use it called encapsulation. Encapsulation improves programs maintainability and reliability. So we can declare a tag type as private and then hide the implementation details from everyone who uses the type. The most common way to hide implementation details is to define a type publicly in a package declaration as a tagged private. Follow each type declaration, the declaration of subprogram that operate on the type. The private part of the package declaration define the types. So what they're telling is ADA provides a one private keyword. Under that you can define the type extension. Like in the public you can define a type and you can extend. So by doing that, any clients cannot be accessible this one. So by that the data of this object can be protected. So you see here same thing what I explained in the previous slide theoretically. It is shown here with the example. File is defined as a target private and the file implementation is given here. What is the attribute it contains. Similarly, ADA file is new file with private. This is the extension of the ADA file. So it's children and ADA file is given and this is the one more procedure which is used to see the ADA file. So one more is abstract types. So it is often useful to declare tag type that won't be used directly to create objects, but instead it will be extended by different types in different types. Such a types are called abstract types. Abstract type must be tag type since only tag types can be extended. To define an abstract, simply put the keyword abstract in front of the keyword tagged in this definition. Subprograms can also be declared as abstract. A call to such subprograms would have to dispatch to an overridden version of the subprograms. To declare a program as subprogram subset, place the parenthesis subset before the last semicolon is definition. This one example. And if you have an abstract subprogram for a given type, the type also must be abstract. When you later create a non-abstract type that descends from the abstract, you must define all of its abstract subprograms. In case there is no overriding version of the subprogram, compiler will not allow to call the subprogram because to call the subprogram argument or return type have to be instantiated and this is not possible. So what does this mean is there are some types which cannot be used directly, which are not directly used. So that types you can declare as abstract and you have to use a tag also because those are the types which are extended. And similarly the programs also can be made as abstract and that programs cannot be called directly anywhere in the programs. Only the overriding version of that abstract programs can be used and the direct call to the in case there is no overriding version and you cannot directly call the normal abstract subprogram, the compiler will throw an error for. So this example you see this set is an abstract null record and this empty union intersection and this union set and take are all abstract programs. This abstract record, this is a normal record. In case there is no overriding version of the subprogram, compiler will not call the subprogram because to call subprogram arguments return had to be shared. This is not possible. The first one what I explained. Subprogram can also be initiated with the abstract keyword. These procedures are not allowed to call directly. So this is one more example. You see, this machine is an abstract tagged private, and this is abstracted type private, and the next one reference is access all this one pointer to the abstract. The machine is a one array, and the turn on turn off is also is abstract procedures, and is on is a normal procedure. You see the machine is this one what I explained you same thing is given in this text and the next thing so user can control the like variable lifeline like initialization finalization and assignments. So ADA provides this feature using the controlled and limited controls. These are defined the ADA finalization. So using the controller controlled control the parameter user can control the assignment, finalization, and initialization. Whereas for the limited control allows him to manage the initialization and finalization. So this is the package, which is a predefined package, which is in the ADA library, which is a type control and limited control. You see, the limited control is also the initial finalization, whereas adjust is also given the option for here. Thank you.